This is Elliot Roush, just showing my milestone 3. So this is animation compression. Pull this up. It's also the compute shader stuff for skinning matrices. So I'll just start by showing the animation compression kind of end result. So for starters, I've set it to kind of the first ratio where I can really see a difference. So this is basically I'm comparing the angle between the quaternions, between the interpolated version and the original keyframe. And then, so if that angle is less than, right now it's 5 degrees, so I set a ratio basically. So this is 0.05 it allows, and that results in results in 6.5 ratio. So this is the first one where I can kind of see a difference. I don't know if you'll pick it up in this video, but basically like the end of his arms, you kind of lose the jiggle, it's more of a smooth animation start to finish. So I'll change the ratio and fire it up again. If we go to our compressor, animation compressor. So this ratio here basically should be between 0 and 1, and that'll go from no compression to full compression, which is just 1 frame. So if I change this up to like, I don't know, say 20%, you start getting a lot more kind of smooth but inaccurate animation, and a much higher compression ratio. So here we can really start to see it's kind of slow to start. He kind of twists his whole body. You can also see kind of if you look at his left foot here, you can see it clip through the floor much more. It's kind of ugly to begin with, actually. But you can see kind of the middle of his foot going into the ground. So it's, a really high compression ratio, but it starts to look pretty janky. So that's just 20% difference basically on the unit circle between what the original keyframe was and what I allow the interpolated keyframe to be rotation-wise. I also have some bounds on translation, but my joints don't generally translate locally, they just rotate. So that's the animation compression. I'll move it back to a lower number here. And then just to kind of show you the shader code, these are my shaders. So interpolating just a single animation, I actually just throw it in the same shader and I just use the same animation. So yeah, saves shader code, doesn't really save performance, whatever. So these are actually the same animations, so I'm just essentially using one of them, keyframe 1, keyframe 2, and a blend factor. Here's my slurp. So I'm calling blend 2 animations. In the case of the monster, I don't have to further blend. The running man will also do a blend between, switching animations. So you can see that when he's running around, basically. I'm crossfading between, say, stand and run, or I'm doing sometimes 3 levels from stand to a 50-50 blend of run and strafe. So that's handled by the animation controller and animation pipeline. So the player has this blend tree, and so each level of that blend will store their local pose. So like strafe and run store a local pose, and then that gets crossfaded with another blend that stores its local pose for the crossfade. So that's where that code lives. But yeah, so it's calling blend 2 animations to extract either 1 or 2 animations from the total, and then blend 2 local poses. So this outputs, basically a single keyframe of joint poses. Can be called 1 or more times. And then compute matrices basically is where I've moved the skinning matrix calculations from, just delete this. I've moved the skinning calculations from the CPU to the GPU. So here we have our magic table is the pose hierarchy, I've called it. Each row has kind of those parent IDs. And then you have multiple rows of that, one for each joint, and that's the pose hierarchy. And then you have the inverse spine pose, and that comes from the skeleton when you load it one time. This is also generated one time based on the skeleton. This is where your local pose is coming in from Blend 2 local poses or Blend 2 animations. And then the skinning matrices block, this comes in one time. Or sorry, this is the output. Skinning matrices, and then that's input, obviously, to like the skin matrix.